A mole is the unit of measurement, and it represents the number 6.02 times 10 to the 23rd, which is also called Avogadro's number. A mole is similar to any unit that represents a number, like a dozen. For instance, if I were to acquire a mole of pennies, then I would have 6.02 times 10 to the 23rd pennies. In the same way, if I were to acquire a mole of, say, shoes, then I would have 6.02 times 10 to the 23rd shoes. However, Amedeo Avogadro was not the one to come up with the mole. Rather, he came up with the idea that equal volumes of different gases at the same temperature and pressure contain the same number of particles. The first person to have coined the term Avogadro's number was Jean-Baptiste John Perrin.
What's the point in this?
Well, to answer your arrogant question, a mole is important because it's convenient when we perform calculations, and it gives us a pretty simple method when we convert between molecules and grams. What sort of calculations and conversions would you do when working with moles? Well, when you're doing conversions of the moles, you have to remember that atoms, molecules, and ions are all the same in these conversions, and you must know how to find the molar mass of an element or compound. Molar mass is the mass of 1 mole of an element or compound. To find the molar mass of an element, you have to refer to the periodic table. In each box on the periodic table, it will have the symbol that represents an element in the center of the box, the atomic number above the symbol, and the atomic mass or the molar mass below the symbol. When you are finding the molar mass of an element, all you have to do is look at the atomic or molar mass in the element's box on the periodic table. However, when you are finding the molar mass for the compounds, it's not that simple. You have to add up the molar masses of all the elements of the compound together, and then you have the whole molar mass of that compound. Once you figure out how to find the molar mass of an element or compound, you can convert between units of grams, moles, or atoms. When you're converting between moles and atoms, you will divide or multiply by Avogadro's number, or 6.02 times 10 to the 23rd. When you're converting between moles and grams, you will divide or multiply by the compound or element's molar mass. Here, I'll show you some examples. Say you wanted to find out how many moles there were in 2.27 grams of sodium chloride. If you are converting from grams to moles, then you have to divide the number of grams by the molar mass of the compound. So first, we would have to find the molar mass of NaCl. Since sodium has a molar mass of 22.99 and chlorine has a molar mass of 35.45, then the molar mass of sodium chloride would be 58.44. Then once you find the molar mass of NaCl, you divide the number of grams by sodium chloride by the molar mass of sodium chloride. That gives you 0.0388 moles of sodium chloride. Another problem to look at is converting between atoms and grams, which involve the use of both Avogadro's number and the molar mass of the substance. Say you wanted to find out how many grams there are of 7.02 times 10 to the 22nd atoms of aluminum. You would have to divide the number of atoms of aluminum by Avogadro's number to get 0.1166 moles of aluminum. Then, in order to get the moles to grams, you have to multiply by aluminum's molar mass. Aluminum's molar mass is 26.98 grams per mole on the periodic table. Once you multiply 0.1166 moles times 26.98 grams per mole, you get 3.15 grams of aluminum. Conversion between moles, grams, and atoms is fairly simple once you figure out the pattern. Does that answer your question? those people that tell others how to build a clock when they ask you what time it is, right? Yeah, and don't ask another question.